quadratic polynomial is equal to x square minus sum of zeros multiply x plus product of zeros. Yes, product of zeros. Now here we have to substitute the values. So here x square, now here quadratic s square minus 4s plus 1. So now compare here, comparing this polynomial with ax square plus bx plus c. Then we get, therefore, a is equal to 4, b is equal to minus 4, and here c is equal to 1 upon 2. And here, students, we consider that first 0 as alpha 1 upon 2, and the second one beta is equal to 1 upon 2. We can simplify this polynomial because of there is a denominator place, there is a 4. So I multiply this by 4, each and every term by 4. So 4 multiply x square plus 4 multiply 1 upon 4x plus 4 multiply 1 upon 4. So that means here, students, p of x, therefore p of x is equal to 4x square plus, now here 4 get cancelled, students, here. So here x plus here also 4 get cancelled, and here the 1. So the exercise 2.2 from the chapter 2 polynomial. So let us solve the exercise 2.2. Here, the first question is, students, find the zeros of the following quadratic polynomials and verify the relationship between the zeros and the coefficient. So now here, students, there is a first question, and the first question is x square. First example is x square minus 2x minus 8. So now here, student, x square minus 2x minus 8 is a quadratic polynomial, students. And here we have to find out the zeros of these quadratic polynomial, students. Okay, so let us start to solve this example. So now here x square minus 2x minus 8. So I write down that x square minus 2x minus 8 this polynomial. Okay, students, now here, students, we want the two numbers, finding out the two numbers such that their product will be minus 8 and their addition or subtraction would be minus 2, students, would be minus 2. So now here, students, which these two numbers, students, that having the product minus 8 and the addition or subtraction minus 2. So these two numbers are, students, 4 2s are 8, and here we want the product minus 8 and the addition or subtraction minus 2. That means here minus 4 and here positive 2. So here product will be minus 8, so the addition will be minus 2. So these numbers are proper numbers that we have to factorize this number, or we can find out the zeros of this polynomial. So now here we first write the quadratic polynomial as it is, and then here, students, I write the first term and the third term as it is. I write the first term and last term as it is, and in between these terms, I arrange these two terms. So that is minus 4x plus 2x. Now here next step is that making the group of two terms. So this is the first one group, this is the second one group, and then now, students, the common in between these two terms. So now here, students, the common in between these two terms are x, here is x, here is x. So common is x, and in the bracket we write x minus 4. Okay, students, and then here plus 2 multiply x plus 2 multiply 4. So now here, students, from this group we common out the 2. In the bracket we write x plus 4. Okay, students, here. So now here, students, that here x minus 4, here plus 2x, so plus 2. Here, students, there is a mistake that we have to write here minus 8. Here is a sign minus 8, students. Okay, so I write down that minus. Now here, students, the two brackets are equal, so I write down only one bracket for that. So here we say in the first bracket x minus 2, and in the second bracket we write the remaining terms. So remaining terms are x plus 2. So I write down x plus 2. Okay, students, now this is the quadratic polynomial, and we have to find out the zeros of this quadratic polynomial. So we say x minus 4 is equal to 0, or x plus 2 is equal to 0. So that means here, students, x is equal to 4, or we say x is equal to minus 2. So now here, students, let first zero of this quadratic polynomial is alpha, so alpha is equal to 4, or we say beta is equal to minus 2 are the zeros of this quadratic polynomial, Okay, students. So now here, students, we got the zeros of the quadratic polynomial, given quadratic polynomial, as alpha is equal to 4 and beta is equal to minus 2. Alpha will be the first solution or first zero of this quadratic polynomial, and beta is the second zero of this quadratic polynomial. Okay, students, now here, students, that first part is over. Okay, students, the first part is over. The next part is that write down the quadratic polynomial as it is. Write down quadratic polynomial as it is. So I write down x square minus 2x minus 8, and I say that comparing this equation, comparing this polynomial with ax square plus bx plus c. Therefore students, we write down, after comparing, we get a is equal to 1, because at the place of a here is 1. So I write down a is equal to 1. Then at the place of b there is minus 2. So I write down b is equal to minus 2. b is equal to minus 2. And at the place of c there is a minus 8. So I write down c is equal to minus 8. Okay, so we have the three values a, b, c. Now here we have to verify the relationship between the zeros and the coefficient. Okay, a, b, c are the coefficient, and alpha and beta are the zeros of the quadratic polynomial. So what is the relationship between these two? So that's why we write down that here. That means we have to prove that alpha into beta is equal to c upon a, and here alpha plus beta is equal to minus b upon a. So that means here students, we have to check out that either LHS and RHS are equal or not. So here LHS is equal to alpha into beta. So here alpha is 4, beta is minus 2. So 4 multiply minus 2, and that means it is equal to minus 8. So LHS is equal to minus 8. And then RHS is students, that is C upon A. RHS is equal to C upon A. So here C is minus 8 and A is here students 1. So that is equal to minus 8. So here RHS is equal to 8. So now here we observe carefully students that LHS and RHS are equal. So here I say that LHS is equal to RHS. LHS is equal to RHS. Okay, in this condition. So that means here students, alpha beta is equal to C upon A is verified. So there is a relation between the coefficient and the zeros of the quadratic polynomial is that alpha into beta is equal to C upon A. And the next one, that is alpha plus beta is equal to minus b upon a. Now here I write down LHS. LHS is equal to alpha plus beta. So here students, alpha, that is 4 plus minus 2. So that means here 4 minus 2. That means here students, LHS is equal to 2. LHS is equal to 2. Now here students, the RHS. What is the RHS students here? The RHS is equal to minus b upon a. So that means here students, minus of minus 2 divided by 1. So minus of minus 2, that means positive 2. So RHS is equal to 2. Here students, RHS is equal to 2. And that means here students, LHS is equal to RHS. Okay students, we have to write that LHS. Therefore, LHS is equal to RHS. And that means here students, alpha plus beta is equal to minus b upon a is verified. So now here students, so this way we can say that there is a relationship between coefficient and the zeros of the quadratic polynomial is alpha plus beta is equal to minus b upon a. So that means here we verified this quadratic polynomial. That is the relation between the zeros and the coefficient. Okay students, then the next example, come to the next example. So here, next example is that 4s square minus 4s plus 1. 4s square minus 4s plus 1. So let us finding out the zeros of this quadratic polynomial. So here, first I write down that students, 4s square minus 4s plus 1. And then here students, that means here we finding out the two numbers such that their product will be positive 4 and their addition or subtraction would be minus 4. Their product will be positive 4 and their addition or subtraction would be negative 4. So which are these two numbers students? So these numbers are students 2, 2. So here 2 2s are 4. But here addition is the minus 4. So I write down here minus 2, minus 2. So the addition or subtraction becomes, addition will be minus 4 and the product will be positive 4. So these numbers are proper. So here we write down that the quadratic polynomial, first I write down the given quadratic polynomial as this way. So now here I write down the first term and the last term as it is. And in between this first term and last term, I arrange these two terms. So minus 2s. Okay. Now make the group of these two terms and make the group of second group for these two terms. Now here they factorize these terms. So 2 multiply 2 multiply s minus 2 multiply s. So now here from this group there is a common, and here is 2, here is 2. Here is s, here is s. So here 2s is a common, and in the bracket we write 2s minus 1. Okay students, 2s minus 1. Then here from the second group we factorize this second group, 2 multiply s plus 1. Okay, so now here no one is the common, that means there is a 1 common. So I write down that minus 1, and in the bracket I write down 2s minus 1. So now here 2s minus 1 are equal bracket. Okay, so that's why I write only the in the first bracket 2s minus 1, and in the second bracket that I write the remaining term. So 2s minus 1 are the remaining term and write down in the second bracket. So 2s minus 1 in the first bracket and 2s minus 1 in the second bracket. Now here students, we have to find out the zeros of the quadratic polynomial. So that's why I say that 2s minus 1 is equal to 0, or 2s minus 1 is equal to 0. Okay, this first bracket is equal to 0, this second bracket is equal to 0. So now here 2s is equal to 1, so s is equal to 1 upon 2. Here also students, 2s is equal to 1, s is equal to 1 upon 2. Okay students, so now here students, so this s, that means the alpha. So alpha is equal to 1 upon 2 and beta is equal to 1 upon 2 are the zeros of the given quadratic polynomial. Given quadratic polynomial. Given quadratic polynomial. Now here students, the first part is over. Now the second part, that here we find out the values of the coefficient, that is a, b, c. So that's why first we write down the quadratic polynomial as it is 4s square minus 4s plus 1. So now here I say that comparing this quadratic polynomial with ax square plus bx plus c. Okay, so then that's why we get a is equal to 4, b is equal to minus 4, and c is equal to 1. Okay students, now this second part is over. Then here students, coming third part. In the coming third part, we verify that the relationship between the coefficient and the zeros of the quadratic polynomial. So here students, so we have to prove this. So we write that alpha into beta is equal to c upon a, and alpha plus beta is equal to minus b upon a. Okay, we have to verify the relationship between the coefficient and the zeros of the quadratic polynomial. That means here students, we have to verify these two results. Students. So now here students, that here LHS is equal to alpha beta. So alpha here is the 1 upon 2, beta is also 1 upon 2. So 1 upon 2 multiply 1 upon 2, that means students here 1 upon 4. LHS is equal to 1 upon 4. Now here students, that is the RHS. Okay, students, RHS. So here RHS is equal to C upon A here students. So C, that is a 1, and A, that is a 4. So here 1 upon 4. So here we say that the RHS is equal to 1 upon 4. So now here C, LHS is equal to 1 upon 4 and RHS is equal to 1 upon 4. Therefore we say that LHS is equal to RHS. LHS is equal to RHS. It means that alpha into beta is equal to C upon A is verified. Okay students, and then the next part is that we have to verify, that is alpha plus beta is equal to minus b upon a, and that means here students, first we write down the LHS, so which is equal to alpha plus beta, that means here 1 upon 2 plus 1 upon 2, that means here 1 plus 1 upon 2, that means here 2 upon 2, which is equal to 1. So here students, LHS is equal to 1, and then students, the RHS. So here students, RHS is equal to minus b upon a. That means here students, minus of minus 4 divided by 4. So now here students, minus of minus 4, that means 4. So 4 upon 4, which is equal to 1. So RHS is equal to 1. Okay students, RHS is equal to 1. So here LHS and RHS are equal. So I say that therefore LHS is equal to RHS. And students, LHS is equal to RHS. That means students, I say that alpha plus beta is equal to minus b upon a is verified. Okay students, that means here our second example is completed. Now come to the third example students. Third example is that 6x square minus 3 minus 7x. Now here we should observe the Example, carefully students, there are the three terms, but these three terms are jumbled out students. So we arrange in a proper manner. We arrange these terms in a proper manner. So 6x square minus 3 minus 7x, that means here students 6x square minus 7x minus 3. Then here students that we want the two numbers such that their product will be minus 18. We finding out the two numbers such that their product will be minus 18 and their addition or subtraction would be students minus 7. So now here which number are such a type of which number that fulfill these two conditions? So the two numbers are 9 2s are 18. 9 2s are 18. And the proper sign, taking the proper sign, that is minus 9 positive 2. So the product will be minus 18 and the addition or subtraction will be minus 7. So now here students, the next part, that is first we write down the quadratic polynomial 6x square minus 7x minus 3. Okay, and then arrange the terms. So write down first term and the last term as it is and arrange these two terms in between them. So minus 9x plus 2x. So now make the group of this first one and this is the second one. So now common out, factor out this. So 3 2s are 6, multiply x minus 3 multiply 3 multiply x, and here plus 2 multiply x minus 3 multiply 1. Okay students, now here from this first group there is a common. So here is 3, here is 3, here is x, here is x. So students 3x is a common. In the bracket we write 2x minus 3. Okay, and here students no one is common, that means there is a one common from this group. So here in the bracket we write 2x minus 3. So now here the two brackets are equal. So that's why students I write 2x minus 3 in the first bracket, and in the second bracket the remaining terms 3x plus 1. 3x plus 1. So now here we have to finding out. We are going to finding out the zeros of the quadratic polynomial students. So that's why I write down here 2x minus 3 is equal to 0 or 3x plus 1 is equal to 0. So here 2x is equal to 3, x is equal to 3 upon 2. And here students 3x is equal to minus 1 and x is equal to minus 1 upon 3. So now here students we say that the first zero of the quadratic polynomial as alpha. So alpha is equal to 3 upon 2 and the second zero of this polynomial is beta. Consider beta and that is equal to minus 1 upon 3. Are the zeros of the polynomial. Are the zeros of the quadratic polynomial. Okay students, quadratic polynomial. Now here first part is over students. Now the second part, that we have to prove that the relationship between the coefficient and the zeros of the quadratic polynomial. So that's why we first write down the quadratic polynomial 6x square minus 7x minus 3, and then comparing this quadratic equation, this quadratic polynomial, comparing quadratic polynomial with ax square plus bx plus c. So therefore we say that a is equal to 6, b is equal to minus 7 and c is equal to minus 3. Okay, now here we have the three coefficient, that is a, b and c. Now here we have to find out the relationship between the zeros and coefficient. That means we have to show that alpha into beta is equal to c upon a and alpha plus beta is equal to minus b upon a. So now here LHS, in this condition, that LHS is equal to alpha beta. So that means here students 3 upon 2 multiply minus 1 upon 3. So here 3 get cancelled. Okay, here students that 3 get cancelled here. Okay, and that's why the answer is minus 1 upon 2. So here LHS is equal to minus 1 upon 2. Now here students the RHS. So RHS is equal to C upon A. So that means here minus 3 upon 6. And that means it is in the simplest form minus 1 upon 2. 3 1s are 3, 3 2s are 6. So here students RHS is equal to minus 1 upon 2. So now here students carefully observe LHS and RHS are equal. So I say that LHS is equal to RHS, and that it implies that alpha into beta is equal to C upon A is verified. Okay, it's verified. Now, second verification students, we write here LHS is equal to alpha plus beta. So here 3 upon 2 plus minus 1 upon 3. So that means here students 3 upon 2 minus 1 upon 3. Okay, 1 upon minus 1 upon 3. So now here students that is cross multiply, 3 3s are 9, minus 2 1s are 2, and here 2 3s are 6. So here 7 upon 6. LHS is equal to 7 upon 6. Okay, so now here students the RHS. What is the RHS students? So RHS is equal to minus B upon A. So that means here students minus of minus 7 upon 6. That means minus of minus, that means positive 7 upon 6. And that is the RHS. So here students carefully observe that LHS is equal to RHS. LHS is equal to RHS. So that means students I write here LHS. Therefore LHS is equal to RHS. It means that alpha plus beta is equal to minus B upon A is verified. Is verified. Okay students? See here carefully. See, observe this. Such a type of the example, such a type of example comes at 2 or 3 marks for examination purpose. And examination purpose, these examples, such a type of the examples are very, very important. So you practice with me students. Okay. Then here come to the next one example students. Come with the next one example. Here the fourth one example, 4u square plus 8u. So this is a quadratic polynomial students. First we have to find out the zeros of the polynomial. Okay, so now here first I write down that 4u square plus 8u. Okay, now here students I factorize that. So 4 multiply u plus here 4 2s are 8 multiply u. So now here in between these two terms there is a common 4 and here u. So 4u is the common and in the bracket we write u plus 2. U plus 2. Now here students we have to find out the zeros of the quadratic polynomial, and that means I write down 4u is equal to 0 or u plus 2 is equal to 0, and that means students here u is equal to 0 upon 4, that means u is equal to 0, and here students u is equal to minus 2. Okay, so now here students that take the first value as alpha, so alpha is equal to 0, and take the second value as solution as beta, so beta is equal to minus 2 are the zeros of the quadratic polynomial. Zeros of the quadratic polynomial. Okay students. Now the next part, that write down the polynomial, write down the quadratic polynomial as it is. So here 4u square plus 8u. Okay, and then I say that comparing this quadratic polynomial with ax square plus bx plus c. Therefore, a is equal to, here we at the place of x square, I write down au square and here u, bu plus c here students. Because in the quadratic polynomial is in the variable u. So I'm comparing this quadratic polynomial with au square plus bu plus c as a general quadratic polynomial. Okay students. So now here a is equal to 4, b is equal to 8 and c is equal to 0. Now the next process is that students, we have to find out the relationship between the coefficient and the zeros of the quadratic polynomial. That means we have to verify that alpha into beta is equal to c upon a and alpha plus beta is equal to minus b upon a. So now here LHS is equal to alpha beta. So here 0 multiplied minus 2. That means LHS is equal to 0. LHS is equal to 0. And here students that RHS. So now here students RHS is equal to C upon A. RHS is equal to C upon A. That means 0 upon 4. 0 upon 4. So here 0 upon 4, that means here RHS is equal to 0. RHS is equal to 0. Now here carefully see that LHS is equal to 0. RHS is equal to 0. That means here students we say that LHS is equal to RHS. LHS is equal to RHS. It means that students alpha into beta is equal to C upon A is verified. Okay students. And then next one students, that alpha plus beta is equal to minus B upon A. So here LHS is equal to alpha plus beta. So here students that 0 plus minus 2. That means here 0 minus 2 and that means minus 2. So here LHS is equal to minus 2. LHS is equal to minus 2. So now here students that RHS. Here students RHS. So RHS is equal to students minus B upon A. That means here minus of, I write down here upper side, that minus 8 upon 4. RHS is equal to minus 8 upon 4. And that means here minus 2. RHS is equal to minus 2. So now here students, LHS and RHS are equal. So that means here students, we say that LHS is equal to RHS. It means that alpha plus beta is equal to minus B upon A is verified. Is verified. Okay students? Students, if you practice such a type of the examples, then you can get this such a type of examples very, very easy. You can easily solve such a type of the example. But practice more. Okay? Then and remind this step. Okay? Do this stepwise. Now the next one example students. So the next one example is students t square minus 50. This is the quick one example students. T square minus 50. Now here I write down this as it is t square minus 50. Okay. So now here students here that we say that here as we have to find out the zeros of this polynomial, then I say that t square minus 15 is equal to 0. So I can write that t square is equal to 15. So that means here students t square is equal to root 15 whole bracket square. Okay, whole bracket square. Now t square is equal to root 15 whole bracket square. So now here students t is equal to plus or minus root 15. So now here students the first zero of the quadratic polynomial is positive root 15 and the second zero of this quadratic polynomial is minus root 15. So I say like that R alpha and beta, alpha is equal to root 15 and beta is equal to minus root 15 are the zeros of the given quadratic polynomial. Given quadratic polynomial. Then next one that I write down this quadratic polynomial as it is t square minus 15. Then we are comparing this quadratic polynomial with ax square plus bx plus c. Therefore, a is equal to 1, b is equal to 0 and c is equal to minus 15. Then here students, next part, that is we have to verify the relationship between the zeros and the coefficient. So that means students, we have to verify alpha into beta is equal to c upon a and alpha plus beta is equal to minus b upon a. So that's why here students I write under LHS is equal to alpha beta. So here students, root 15 multiply root 15 minus root 15. Okay students, so now here students, that is the root 15 minus root 15, that means here students we write that minus 1 and root 15, that means here students 15 and that means here students LHS is equal to 15. LHS is equal to 15. Now the RHS students, here. So here RHS is equal to C upon A. Here, that means here students minus 15 upon 1. Minus 15 upon 1. That means here students RHS is equal to minus 15. Here also students, yes, here is minus sign, minus 15. So here LHS and RHS are equal. Here LHS and RHS are equal. So I write down here, therefore LHS is equal to RHS. And it means that students alpha into beta is equal to C upon A is verified. Okay students, and then next part, that is alpha plus beta is equal to minus B upon A here. So students LHS is equal to alpha plus beta. So here students that root 15 plus in the bracket minus root 15. So root 15 minus root 15. So that means LHS is equal to 0. LHS is equal to 0. Then here students RHS is equal to minus B upon A. So that means here students minus 0 minus 0 upon 1 and RHS is equal to 0. RHS is equal to 0. And that means students here see RHS and LHS. LHS is equal to RHS. And it means that students, it means that alpha plus beta is equal to minus C upon, minus B upon A. Is verified. Is verified. Okay, students? So such a way we can get the relationship between, we have to verify the relationship between the coefficient and the zeros of the given quadratic polynomial. So now let us see the next one question, students. Students, 3x square minus x minus 4. So now here, students, first we have to find out the zeros of the quadratic polynomial. First I arrange these terms. I write down this quadratic polynomial as it is. Now here, students, we have to find out the two numbers such that their product is minus 12. Their product is minus 12 and their addition or subtraction will be, students, minus 1. So which are such a type of the numbers? The numbers are 4 3s are 12. So 4 and 3, and by giving the proper sign I write here minus 4 positive 3. So now here write down quadratic polynomial as it is 3x square minus x minus 4, and I arrange these terms in between these. So I write down the first term as it is and the last one as it is, and in between that I arrange the minus 4x and plus 3x. Now making the first group this one and making the second group for these two terms. So now here factorize this 3 multiply x minus 2 multiply x. Okay, and then the second group, that is the 3 multiply x minus 4 multiply 1. So now here from this first group, the common is x is here, x is here. So x is common, and here in the bracket we write 3x minus 4. And here, students, plus here no one is common, that means 1 is common, and we write in the bracket 3x minus 4. So that means here in the first bracket we write 3x minus 4, and in the second bracket we write x plus 1. So now here we have to find out the zeros of the quadratic polynomial. So I write down 3x minus 4 is equal to 0, or x plus 1 is equal to 0. So that means here, students, 3x is equal to 4. So x is equal to 4 upon 3. And here, students, x is equal to minus 1. So now I take the first solution as alpha and the second solution as beta. So alpha is equal to 4 upon 3 and beta is equal to minus 1. Are the zeros of the quadratic polynomial. Zeros of the quadratic polynomial. Now here, students, the next one, I write down the given polynomial as it is. That is 3x square minus x minus 4. And then comparing this quadratic polynomial with ax square plus bx plus c. Therefore, students, a is equal to 3, b is equal to minus 1, and c is equal to minus 4. Now, the next one part is that, students, we have to verify the relationship between coefficient and the zeros of the polynomial. That means we have to verify alpha into beta is equal to c upon a, and alpha plus beta is equal to minus b upon a. So here, students, LHS is equal to alpha into beta. That means here, students, 4 upon 3 multiply minus 1. So here minus 4 upon 3. LHS is equal to minus 4 upon 3. Okay, students? And then here, students, the RHS. Here, RHS is equal to C upon A, and that means, students, minus 4 upon 3. Minus 4 upon 3. RHS is equal to minus 4 upon 3. So here, students, see, carefully observe, LHS is equal to RHS. LHS is equal to RHS. And that means, students, here, it means that alpha into beta is equal to C upon A is verified. Alpha into beta is equal to C upon A is verified. Now here, students, here the second part, that is alpha plus beta is equal to minus B upon A. So here LHS is equal to alpha plus beta. So here 4 upon 3 plus minus 1, so that means 4 upon 3 minus 1, that means 4 minus 3, 4 minus 3 upon 3, so that means here LHS is equal to 1 upon 3. LHS is equal to 1 upon 3. And here students, the RHS, here students, RHS. So RHS is equal to minus B upon A, that means here students, minus of minus 1, minus 1 upon 3, and that means minus of minus, that means positive 1 upon 3, and which is equal to RHS. So RHS is equal to 1 upon 3. Now here students, LHS and RHS are equal. So LHS is equal to RHS. It means that students, it means that alpha plus beta is equal to minus B upon A is verified. Okay, is verified. So such a way here students, such a type of the examples are very easy and you can solve it because this is the simplest method. So let us see the second question students. Find a quadratic polynomial each with the given numbers as the sum and product of its zeros respectively. So now here students, the first question is for the two numbers 1 upon 4 and minus 1. What are these numbers students? So here students, the first number, that is the 1 upon 4, is the sum of the zeros. So here students, in the given I write sum of the zeros. Sum of the zeros is equal to 1 upon 4. And students, the second number, that is the product of zeros. That is the product of the zeros. So product of the zeros is equal to minus 1. Okay students, then here students, we have to find out the quadratic polynomial. So there is a formula for the quadratic polynomial students, and that formula is that quadratic polynomial is equal to x square minus sum of the zeros multiply x plus product of the zeros. Then students, substitute the values in this formula. So here x square minus sum of the zeros, that means here 1 upon 4 multiply x, and here product of the zeros, that means minus 1. And here we write here p of x, that polynomial in the x variable. So here p of x is equal to students x square minus 1 upon 4x minus 1. Okay, if you want to simplify this polynomial, then it will be written as that multiplying both the sides by 4. So 4x square multiply 4 multiply 1 upon 4x minus 4 multiply 1. That means students 4x square minus x minus 4. So this is our final quadratic polynomial. Okay students, so such a way you can find out the quadratic polynomial. Okay students, then next one example students, it is for the number root 2 and 1 upon 3. So now here students, first I write down the given here students. So given is that sum of zeros is equal to root 2. Then here product of zeros is equal to 1 upon 3. Now here we have to find out the quadratic polynomial. So I write down the formula here. Quadratic polynomial is equal to x square minus sum of zeros multiply x plus product of zeros. Now here we have to substitute the values. So here x square, now here quadratic polynomials, we write the quadratic polynomial in terms of x students. So I write p of x here. So x square minus here sum of zeros, that is root 2 x plus product of the zeros 1 upon 3. Okay students, now here we simplify this quadratic polynomial. So p of x is equal to x square minus root 2x plus 1 upon 3. Now here students, at the denominator place there is a 3. So in a simplest form, that I multiply each and every term by 3. So 3 multiply x square minus 3 multiply root 2x plus 3 multiply 1 upon 3. Okay, then that means students p of x is equal to 3x square minus 3 root 2x plus 1 because 3 get cancelled. So now here students, this is our required quadratic polynomial. Okay students, now come to the next one example students. The next one example is that 0 and root 5. These are the two numbers. So now here first in the given, first I write down the given sum of zeros is equal to 0. Product of zeros, here product of zeros is equal to root 5. Then next one part, that is the formation of quadratic polynomial. So I write down first the formula. Quadratic polynomial is equal to x square minus sum of zeros multiply x plus product of zeros. Then students, we substitute these values. So for the quadratic polynomial, I write this quadratic polynomial with respect to m students. With respect to m. Then p of m is equal to, no here students, I write down x here, so I write down here x. So p of x is equal to x square minus sum of 0 x and plus here product of zeros, that is root 5. Then here students, final answer is p of x is equal to x square minus 0x plus root 2 plus root 5 plus root 5. So that means here students, p of x is equal to x square plus root 5. So this is our required quadratic polynomial students. Okay students, very easy examples. First carry out the steps here as per I follow that. Okay, you should have to write down the formula. Now here students, the next one example. The next example is student 1, 1. So here I write down the given. Here students. So given is that sum of zeros is equal to 1. Product of zeros is equal to 1. And then here students, that I write down the formula for the quadratic polynomial here. So I write down here quadratic polynomial is equal to, so I write down this quadratic polynomial with respect to m students. So here I write down m square minus sum of zeros multiply m plus product of zeros. Okay. Then here students, that quadratic polynomial in terms of n, so p of n is equal to n square minus 1x plus 1. So here we get the required quadratic polynomial as p of n is equal to m square minus n plus 1. So this is the required quadratic polynomial. Okay students, this is the required quadratic polynomial. Okay. Then next one example students. Numbers are minus 1 upon 4 and 1 upon 4. So here first I write down the given. Students. Sum of zeros is equal to minus 1 upon 4 and product of zeros is equal to 1 upon 4. Then write down the formula for quadratic polynomial. So here students, quadratic polynomial is equal to x square minus sum of zeros multiply x plus product of zeros. Then here students, that quadratic polynomial with respect to x students, so it is p of x is equal to x square minus sum of zeros is minus 1 upon 4. So I write here minus 1 upon 4x plus product of zeros, that is 1 upon 4. So now substitution is over. Then simplification. So I simplify here students. So here p of x is equal to x square. Now here minus 1 upon 4x students. So I write down plus 1 upon 4x plus 1 upon 4x and plus 1 upon 4. Okay, students. Now here further we can simplify this polynomial, students. So p of x is equal to, we can simplify this polynomial because of there is a denominator place, there is a 4. So I multiply this by 4, each and every term by 4. So 4 multiply x square plus 4 multiply 1 upon 4x plus 4 multiply 1 upon 4. So that means here, students, p of x, therefore p of x is equal to 4x square plus, now here 4 get cancelled, students, here. So here x plus here also 4 get cancelled and here the 1. So therefore we can say p of x is equal to 4x square plus x plus 1, and which is the required quadratic polynomial. Okay, students. Then next one example, students. That will be the second one example, and the numbers are 4 and 1. So now here first we write down the given, students. First we write down the given. So sum of zeros is equal to 4 and product of zeros is equal to 1. Then write down the formula, that is quadratic polynomial is equal to x square minus sum of zeros multiply x plus product of zeros. Then substitution, students, that first I write down p of x is equal to x square minus sum of zeros is 4. So here x plus, students, product of 0 is 1. Then here students simplify here, that p of x is equal to x square minus 4x plus 1. Okay, so this one is the required quadratic polynomial. Okay, students, so such a way this exercise 2.2 completed. And here students, that if you like our content, then subscribe our channel, share our videos to your friends.